It's just a valley, a small gorge carved by the Dussel River near Dusseldorf, Germany. Today, it's green, wooded, pleasant. But it used to be different. It was a place of industry, a limestone quarry where men blasted rock and hauled it away. It was noisy and dusty. Nothing special, except this valley, the Neander Valley, or Neanderthal in German, is one of the most important places on Earth for understanding who we are. It's not because of what was built there, it's because of what was found there. To get why it's so important, you have to picture the world in 1856. People's ideas about the past were very different. The story of human origins was mostly a religious one, a story of creation of Adam and Eve. The idea that Earth was incredibly old, millions of years old, was still new and controversial. The idea that life had evolved over these vast stretches of time was even more radical. Charles Darwin was still quietly working on his big book on the origin of species. It wouldn't be published for another 3 years. In this world, there was just one kind of human us. Any strange bones found in the ground were explained away. Maybe they belonged to a bear. Maybe they belonged to a person with a strange disease. They were curiosities, not clues to a lost world. And then in August of 1856, workers at the Feldhofer cave in the Neander Valley were clearing out clay to get to the limestone underneath. As they dug, they found some bones. A skull cap, thick and heavy, with a pronounced brow ridge. Some sturdy limb bones. They weren't like any bones they had ever seen. The workers thought they might belong to a cave bear. They tossed them aside with the rest of the debris. Luckily, the quarry owner had a different idea. He thought they were interesting and gave them to a local teacher and amateur naturalist named Johann Karl Fulrott. This is where the story really begins. Fulrott was not a world-famous scientist. He was just a curious, intelligent man. He looked at the bones and knew almost immediately that they weren't from a bear. They were human, but they were a strange kind of human. The skull was long and low, not rounded like a modern person's. The bones were incredibly thick and powerful. Fulrott took the bones to Hermann Schaffhausen, a professor of anatomy in Bonn. Schaffhausen was a more established scientist, and he agreed with Fulrott. They believed they had found a new ancient type of human, a primitive race that lived in Germany long before any recorded history. They presented their findings in 1857. They were arguing that these bones belonged to a person who lived and died in a time when mammoths and woolly rhinos roamed Europe. The scientific establishment was not impressed. In fact, it was hostile. The most powerful voice in German science at the time was Rudolf Virchow. He was a brilliant pathologist, a giant in his field, but he was also deeply conservative when it came to human origins. He looked at the Neanderthal bones and dismissed them completely. He claimed the thick brow ridge was caused by blows to the head. The bowed leg bones, he said, were the result of rickets, a bone disease. He concluded it was simply the skeleton of a deceased Cossack soldier who had crawled into the cave to die during the Napoleonic Wars a few decades earlier. A pathological oddity, a nobody. And because Virchow was so influential, his opinion carried the day. The Neander Valley man was dismissed as a freak, an aberration. The story could have ended there. A weird set of bones in a German museum, a footnote in a scientific debate. But it didn't. The Neander Valley find was the first rock thrown into a still pond. The ripples started to spread, slowly at first, then faster. The first big ripple was Darwin. When On the Origin of Species was published in 1859, it provided a framework. It gave scientists a theory, evolution by natural selection, that could explain how a different kind of human might have existed. Suddenly, the idea of an ancient primitive human wasn't so crazy. It was actually predicted by the theory. The second ripple was more fossils. If the Neander Valley man was a one-off, a diseased soldier, then there shouldn't be any more like him. But there were. A few years earlier, in 1848, a similar skull had been found in Gibraltar, but no one knew what to make of it at the time. After the Neander Valley discovery, people looked at it again with new eyes. Well, it had the same features. Then, in 1886, 2 more skeletons were found in a cave at Spy, in Belgium. They were found alongside the bones of extinct animals and with stone tools. There was no denying it anymore. This wasn't a diseased individual. This was a population and a species. They were named Neanderthals, after the valley where they were first recognized. So, the first reason the Neander Valley is so important is this. It was the place where humanity was forced to look in the mirror and see a different face staring back. It was the first recognized fossil human ancestor. It shattered the idea that we were special, unique, and unchanged since creation. It opened the door to the entire field of paleoanthropology, the study of human evolution. It was the beginning of a long, difficult, and fascinating journey to uncover our own family tree. They gave us a relative. After the initial discovery and the battles over its authenticity, the real work began. What were these Neanderthals actually like? For a long time, the image was not a flattering one. Early reconstructions, especially one based on a skeleton from La Chapelle-aux-Saints in France, portrayed them as stooped, brutish, dim-witted cavemen. The skeleton was of an old man, riddled with arthritis, which made him look hunched over. But the image stuck. The word Neanderthal became an insult for someone stupid or uncivilized. This image was deeply wrong, and the slow, patient work of science over the next century has proven just how wrong it was. The importance of the Neander Valley grows because it gave us the first member of a group that we have come to understand as deeply complex and capable. Let's start with what they looked like. They were not just primitive versions of us. They were different, adapted to a different world. They lived during the Ice Age in a cold, hard Europe. Their bodies showed it. They were shorter and stockier than most modern humans, a build that's good for conserving heat. Their bones were incredibly robust, with thick walls and large attachment points for muscles. These were powerful people, men and women. They had a large, barrel-shaped chest, housing big lungs to fuel an active, demanding lifestyle. And their heads were different. Their skulls were long and low, not high and round like ours. They had a distinctive occipital button, a bulge at the back of the skull. Their faces were dominated by a large nose and a projecting mid-face. And of course, there was the famous brow ridge, a solid bar of bone over the eyes. For a long time, people wondered why they had these features. The big nose might have been an adaptation to warm and moisten the cold, dry Ice Age air before it hit their lungs. The brow ridge, we still don't know for sure. Maybe it was for structural support for powerful chewing. Maybe it was just a genetic trait that grew along with their large faces. But the most surprising thing about their skull was what was inside it. Their brains were, on average, slightly larger than ours today. Brain size isn't a direct measure of intelligence, but it tells us one thing for sure: they were not simple-minded brutes. They had the biological hardware for complex thought, and the evidence for that complex thought is everywhere. Look at their tools. Neanderthals were masters of a technology called the Mousterian industry. It was a major step up from the tools made by earlier hominins. They didn't just find a rock and bash it into a crude chopper. They had a plan. They would carefully prepare a core of stone, like flint, and then strike off flakes in a precise way to get a specific shape. This is called the Levallois technique. It requires forethought, skill, and the ability to teach and learn. It shows they could think in steps, to visualize a finished product before they started. They made dozens of different types of tools: spear points for hunting, scrapers for cleaning animal hides, knives for butchering. These were not primitive clubs. They were the Swiss Army knives of the Ice Age. They used these tools to survive in a very tough world. For a long time, people thought Neanderthals were mainly scavengers, picking at the leftovers from other predators. We now know this is false. They were the apex predators of their time. Chemical analysis of their bones shows they ate a lot of meat. They hunted big, dangerous animals: mammoths, woolly rhinos, giant cave bears, bison. You don't hunt a mammoth by being stupid. You do it with cooperation, planning, and courage. They likely used wooden spears, tipped with their sharp stone points, to ambush and bring down these huge animals. It was a dangerous life. Neanderthal skeletons often show evidence of traumatic injuries, similar to the kinds of injuries you see in modern rodeo riders. They got thrown around, gored, and trampled, but they kept going. Survival in the Ice Age also meant controlling fire. And Neanderthals did. They used fire to stay warm, to cook their food, to keep predators away at night, and likely to harden the tips of their wooden spears. A hearth wasn't just a fireplace. It was the center of their social world. It was where they gathered, shared food, and likely told stories. Perhaps the most human thing about them was how they treated each other. For a long time, the idea of a compassionate Neanderthal seemed ridiculous. But the bones tell a different story. The old man from La Chapelle-aux-Saints, the one used for the brutish reconstruction, was not just old. He had lost most of his teeth and had severe arthritis. He couldn't have hunted or even chewed tough meat effectively. But he lived to an old age. This means someone was taking care of him. Someone was probably preparing his food for him. An even more striking example comes from Shanidar Cave in Iraq. One skeleton, called Shanidar 1, belonged to a man who had suffered a crushing blow to the side of his head when he was young. It would have blinded him in one eye and likely damaged his brain. His right arm was withered and had been amputated above the elbow. He was also deaf and had a limp. In the harsh world of the Ice Age, a person with these disabilities would not have survived a week on their own. Yet he lived for years, maybe decades, after his injuries. He was cared for by his group. Saying this isn't the behavior of unfeeling brutes. This is empathy. This is compassion. This is family. There's also evidence that they buried their dead. In several sites like La Chapelle and Chanadar, skeletons have been found carefully placed in pits. They weren't just thrown in a hole, they were arranged, sometimes in a flexed, sleeping position. At Chanadar, one barrel contained clumps of pollen from different flowers. This led to the idea that the flower burial was an intentional, symbolic act. Maybe they laid their dead to rest with flowers. This interpretation is still debated. Maybe the pollen blew in or was brought in by rodents, but the evidence for intentional burial is strong. And burying the dead implies something profound. It suggests an awareness of life and death. It suggests grief. It might even suggest a belief in an afterlife. This leads to the biggest questions. Did they have art? Did they have language? The evidence for art is more controversial than for burial. They didn't paint great murals like the ones modern humans later created in caves like Lascaux. But they did use pigments. They collected lumps of black manganese and red ochre. They seem to have used them to color things, maybe their own bodies, maybe animal skins. In a cave in Spain, scientists found perforated seashells covered in pigment, which were likely worn as jewelry. At another site, a collection of eagle talons were found with cut marks, suggesting they were also part of a necklace or ornament. This is symbolic behavior. Jewelry has no practical purpose. It's about identity, about beauty, about sending a message. And what about language? Could they speak? Their brains were certainly large enough. We also have genetic clues. We share a gene with them, FOXP2, which is crucial for the development of speech and language in modern humans. The Neanderthal version is essentially the same as ours. Physically, their voice box was positioned slightly differently than ours, so their voice might have sounded different, perhaps higher pitched and more nasal. But they had the key bone, the hyoid bone, which anchors the tongue muscles needed for speech. The pieces are all there. It's almost certain they had a complex vocal communication. They weren't just grunting, they were talking. They were sharing knowledge, planning hunts, teaching their children, and mourning their dead. So, the Neander Valley is important because it gave us a name and a face for this other humanity. A humanity that was not a failed experiment or a clumsy rough draft of us, but a successful, intelligent, and resilient people who thrived in a brutal world for hundreds of thousands of years. They were not our ancestors, but our cousins. And for a time, we shared the world with them. This brings us to the most recent and perhaps most mind-blowing chapter of the Neanderthal story. A chapter that once again revolutionizes our understanding and makes the Neander Valley's legacy even more personal. This chapter wasn't written with shovels and brushes in a dusty cave. It was written in a clean, sterile laboratory with DNA sequencing machines. For over a century, our knowledge of Neanderthals came from their bones and their tools. We could infer their behavior, but we could never really know them. We thought they were a separate lineage that went extinct, a dead branch on the family tree. Then, in the 1990s, a Swedish scientist named Svante Pääbo and his team decided to try something that seemed like science fiction to extract and read the genetic code of a Neanderthal. It was an almost impossible task. DNA degrades over time. After tens of thousands of years, all that's left are tiny, fragmented pieces. And these fragments are buried in a sea of contamination from bacteria, from fungi, and from the modern humans who handle the bones. It was a monumental challenge. Their key sample came from the original place. They went back to the bones found in the Feldhofer cave in 1856, the very bones that gave Neanderthals their name. After years of painstaking work developing new techniques to isolate and piece together the ancient genetic fragments, they did it. In 2010, they published the first draft of the Neanderthal genome. This was a scientific triumph on par with the moon landing. It was like finding a book written in a lost language and suddenly being able to read it. The genome gave us incredible insights into Neanderthal biology. It told us about their metabolism, their immune system, even that some of them likely had red hair and pale skin. But the most shocking discovery came when they compared the Neanderthal genome to the genomes of people living today. They expected to find that Neanderthals were a completely separate group. They were wrong. They found that everyone outside of Africa, every person of European or Asian descent, has a little bit of Neanderthal in them. About 1 to 4% of their DNA is of Neanderthal origin. What does this mean? It's simple and it's profound. At some point after our direct ancestors, Homo sapiens, left Africa, they met Neanderthals. And they didn't just fight them or ignore them, they had children with them. There was a time, probably between 50,000 and 60,000 years ago in the Middle East, when our two human lineages mixed. The Neanderthals are not completely gone. A piece of them lives on in us. That DNA isn't just junk. It had real effects. Some of the genes we inherited from Neanderthals are related to our immune system. They gave us genes that helped us fight off local viruses and bacteria that our African ancestors had never encountered. It was a genetic shortcut to adapting to a new continent. Other Neanderthal genes influenced our skin and hair, possibly helping us adapt to the lower levels of sunlight outside the tropics. Of course, it's not all good. Some Neanderthal DNA has been linked to an increased risk for things like type 2 diabetes, depression, and certain autoimmune diseases. It's a mixed legacy, but it's our legacy. This discovery changes everything. It means the story of human evolution isn't a simple ladder of progress, with one species neatly replacing another. It's a messy, tangled bush with branches that met and intertwined. For a time, the world was a much more interesting place. A world with multiple kinds of intelligent, talking humans walking the earth at the same time. It also forces us to ask the final, sad question. If they were so smart, so adaptable, and if we even interbred with them, where did they go? Why are we the only ones left? Neanderthals disappeared from the fossil record around 40,000 years ago, not long after modern humans arrived in Europe in large numbers. There's no simple answer. It was likely a combination of factors, a perfect storm that extinguished their flame. The climate was becoming increasingly unstable, with rapid, wild swings between cold and warm periods. This would have stressed their food sources. The Neanderthal population was also always very small. Genetic evidence suggests their total population at any one time might have been only in the thousands or low tens of thousands, spread thinly across a vast area. They were living on the edge, and then we showed up. Homo sapiens. We came out of Africa in much larger numbers. We might have had slightly more sophisticated social networks, allowing for larger groups and more extensive trade. Maybe our technology, while not vastly superior, was a little more flexible. Maybe we had projectile weapons, like spear throwers, that allowed us to hunt more safely and effectively. It probably wasn't a war of extermination. It was more likely a slow process of competition. In a tough environment, a small advantage can make a big difference over thousands of years. As modern human populations grew, Neanderthal groups would have become more and more isolated. They were likely just outcompeted and gradually absorbed. The interbreeding itself might have been part of their end. If small Neanderthal bands were encountering larger bands of modern humans, their genes might have simply been swamped, diluted into our much larger gene pool. They didn't so much vanish as fade away, leaving a faint echo in our DNA. So why is the Neander Valley so important? It's not just a place on a map, it's a starting point. It's the place where a few bones found by chance by quarry workers completely changed our understanding of ourselves. It gave us a name for our closest extinct relative, transforming a mythical caveman into a real complex person. It launched a scientific quest to understand who the Neanderthals were, revealing them to be intelligent hunters, skilled toolmakers, and compassionate kin. It provided the original genetic material that proved they are not entirely extinct, that a part of them lives on in billions of people today. The importance of the Neander Valley is that it took us, a species that thought it was alone and special, and gave us a family. It gave us a long-lost cousin, a cousin who was different from us in some ways, but so very similar in the ways that truly matter. They loved, they grieved, they cared for each other, they survived in a hard world for an immense stretch of time. The bones from that small German valley were the first whisper of a deep and complicated human story. A story that we are still learning to read, a story that is ultimately our own.